Objective 2. Factor trinomials of the form ax squared plus bx plus c. Method 1, trial and check. Method 2, grouping. Let's factor 25x squared plus 20x plus 4. Well, wow. Some possible factors of 25x squared are x times 25x, or 5x times 5x. Some possible factors of 4 are 1 times 4 or 2 times 2. We would need to methodically try each pair of factors until we find a combination that works or exhaust all of our possible pairs of factors. And keep in mind that because some of our pairs are not identical factors, we may have to exchange some pairs of factors and make 2 attempts before we can definitely decide a particular pair of factors will not work. We'd be looking for a combination that gives the sum of the products of the outside terms and the inside terms equal to 20x. I'm not going to go through this. This is trial and error. Trial and error. It works when it works. But you should never depend on trial and error. The key word in guess and check is guess. And why guess? Why put yourself through the stress? Look at how many possibilities there are. When there's a method that will work every time. So let's skip ahead to the method that works every time. We're skipping, we're skipping, we're skipping, we're skipping. We learned factoring by grouping for a reason. And that reason is so that we could factor trinomials of the form ax squared plus bx plus c. This method is also called the AC method. A being the number in front of the x squared, c being the constant, including the signs of A and C. Similarly to our other method, we're going to multiply to try to get something, and we're going to add to try and get something. Previously, we multiplied just to get C, but we're actually multiplying to get AC. That's why this is called the AC method, because our multiplication goal is AC. So drill that into your head, AC. AC is the multiplication goal, not just C. In fact, what happens when A is 1? When A is 1, then AC is just C. And that's why the other method just had us looking for multiplication to C. It's boring to say C times 1 every time. But now we're looking for AC. The addition goal is still just B. Instead of putting these into parentheses directly, we use the numbers we find to rewrite the middle term. That'll turn it into 4 terms, which we can then factor by grouping. So 8x squared minus 14x plus 5, let's factor. First step is GCF if we can. There is no GCF. So this is definitely an ax squared. We need to use the AC method. A times C is 8 times positive 5. That's positive 40. Our multiplication goal is that positive 40. Our addition goal is negative 14. So what are the factors of 40? Well, we're looking for negative ones because they have to multiply to give us the positive 40. They need to add to give us negative 14. So that makes them both negative. Negative 40 and negative 1, that adds to negative 41. Negative 20 and negative 2, that adds to negative 22. Negative 10 and negative 4, that adds to negative 14. We don't have to keep going. Negative 14 was the one we were looking for. Our numbers are negative 10 and negative 4. Don't throw them in parentheses. Instead, we want to rewrite minus 14x using these two numbers, minus 10x minus 4x, or minus 4x minus 10x. Either way will work. So you see the middle term in blue. We've rewritten it in blue. Where did those numbers come from? They're the two numbers that multiplied to that multiplied to positive 40 and added to negative 14. Negative 10 and negative 4. Now we're going to factor that 4-term polynomial by grouping. From our first two terms, we can factor out a 4x. That'll leave us with 2x minus 1. From the second two terms, we can factor out a negative because it's minus. We have to factor out the negative. And it'd be a negative 5 that we can take out. And when we factor out a negative 5 times 2x is negative 10x. Negative 5 times negative 1 is positive 5. Our common factor is 2x minus 1. Our leftover piece is 4x minus 5. Check by foiling. First, 2x times 4x, that's 8x squared. Outer, 2x times negative 5, that's negative 10x. Inner, negative 1 times 4x, that's negative 4x. Combine those like terms, negative 10x minus 4x is negative 14x. Finally, last, negative 1 times negative 5 is positive 5. 8x squared minus 14x plus 5. We multiplied, we got our original back. We know we are correct. We didn't have to guess around. Is it 2x and 4x? Is it 4x and 2x? Is it 8x and x? Is it x and 8x? And then with all those combinations, is it negative 5 and negative 1? Is it positive 5 and positive 1? Is it negative 1 and negative 5? Is it positive 1 and positive 5? And then we'd have to FOIL each of those to see which one gave us negative 14x. Trial and error is long, it's exhausting, and depending on what you come up with, it is possibly incomplete. What if what you're missing is the correct answer? Instead, use the AC method, do factoring by grouping, get the answer every time. No need to guess and check. Added bonus of having work to show. Next up, 6x squared minus 2x minus 20. Step 1, if there's a GCF, factor it out. There sure is. We can factor out a 2. When we do that, we're left with the leftover piece of 3x squared minus x minus 10. Why? 2 times what is 6x squared? 3x squared. 2 times what is negative 2x? 2 times negative x. 2 times what is negative 20? 2 times negative 10. Now we're going to go ahead and factor the 3x squared minus x minus 10. We're going to use the AC method. A is 3, C is negative 10. A times C, 3 times negative 10, that's negative 30. So we need to find two numbers whose product is negative 30, multiply to negative 30, that add to negative 1. Those numbers are negative 6 and positive 5. Negative 6 times positive 5 is negative 30. Negative 6 plus 5 is negative 1. We rewrite the middle term, rewrite minus x as minus 6x plus 5x. Where did those numbers come from? The minus 6 and the plus 5? They came from the numbers that multiply to A, C, and add to B. Then we take that and we factor by grouping. Group the first two terms. What can we take out? We can take out a 3x. 3x times what is 3x squared? X. 3x times what is negative 6x? Negative 2. Then we can take out a 5, specifically a positive 5. 5 times what is 5x? 5 times x. 5 times what is negative 10? 5 times negative 2. So now we see we have the x minus 2 in common. We factor that out. Our leftover piece is 3x plus 5. We can FOIL to see that that is correct. Two x squared plus 9x plus 4. What's AC? AC is positive 8. Positive 2 times positive 4. We want to find two numbers that can multiply together to get 8 and add together to get 9. Why 9? Because that's B. Those numbers are 1 and 8. Let's use 1 and 8 to rewrite plus 9x. That's plus x plus 8x. Plus 1x plus 8x. Group the first two terms, the 2x squared plus x, and we can factor out an x. The second two terms, we can factor out a positive 4. Both times, that leaves us with 2x plus 1. Factor out the 2x plus 1, and we're left with x plus 4. We can check, and when we FOIL, we get our original back. Let's do another. 8x squared plus 10x minus 3. What's AC? Be specific, positive or negative. AC is negative 24. 8 times negative 3. So we need the numbers that can multiply to negative 24 and add to positive 10. Why 10? Because that's B. So what are some things that multiply to negative 24? Ooh, and one has to be plus, one has to be minus. 8 and 3, 6 and 4, 24 and 1, purposely avoiding it. How about 12 and negative 2? 12 times negative 2 is negative 24. 12 plus negative 2 is positive 10. So we're going to use these numbers, 12 and negative 2, to rewrite plus 10x. So instead of plus 10x, we have plus 12x minus 2x. Or minus 2x plus 12x. Either way, you will get the same answer. You'll just have a different binomial that factors out and a different leftover piece. But you'll still have the same two final factors, just in the different order. Group the 8x squared plus 12x, and we can factor out a 4x. Group the negative 2x minus 3, we can factor out a negative 1. In both cases, the leftover piece is 2x plus 3. That 2x plus 3 is our next common factor. We factor that out, and we're left with 4x minus 1. When we check by foiling, we do get the correct answer. That rule where we multiply to get the number on the end, the constant, add to get the coefficient of the x, that was only for when the coefficient of x squared is 1. Now let's take a look at what we can do if there is a different coefficient of x squared. If there's something like a 2x squared or a 3x squared. The example I'm going to do is 12x squared minus 5x minus 2. Here, we can't just say, I want to find the numbers that multiply to negative 2 and add to negative 5. Because we can only do that if it was just x squared. Here, we have 12x squared. The first method we're going to look at is called the AC method. Named such because AC, or A times C, is our first step. We look at what our A is, we look at what our C is, and we multiply them together to get our AC. And here, A times C would be 12 times negative 2, which would be negative 24. This is our multiplication goal. It's not just C, it is A times C. Our addition goal is still going to be B. And here B is -5. So our multiplication goal is whatever we get when we multiply A times C. Our addition goal, just like before, is the number in front of the X. In this case, -5. So we're going to do the same sort of thing. We need numbers that multiply to -24. And there's a lot of them, but we want the ones that add to -5. So to get a negative number when we multiply, it has to be positive times negative. So we can have 24 and 1. We can have 12 and 2. Three works. We could have 3 and 8. Four is a thing. We can have 6 and 4. So the 4 sets of numbers that multiply to 24 would be 24 and 1, 12 and 2, 8 and 3, 6 and 4. In order for it to be negative, it has to be a positive by a negative. So these are the 8 possibilities. We want the ones that add to -5. -24 minus 1, that's 23, positive. -24 plus 1, that would be -23. Positive 12 plus -2, or positive 12 minus 2, that's positive 10. -12 plus 2, -10. Positive 8 minus 3, that's positive 5. -8 plus 3, that's -5. That's the one we want. We don't have to keep going, but just in case you had them in a different order, 6 minus 4 would be positive 2. -6 plus 4 would be -2. This time, we can't just put the numbers in parentheses. This time, we're going to use the numbers so we had 12x squared minus 5x minus 2. We're going to use the numbers to split the middle term into 2 terms using the 2 numbers we found, -8 and positive 3. So we found -8 and positive 3. That means -5x can be written as -8x plus 3x. And then we'll go ahead and have our -2 and our 12x squared. 4 terms. What can we do? From the last lecture, factoring by grouping. So the AC method is primarily going to be a factoring by grouping problem. So what do? We group the first two. Look for what can be factored out. 12 and 8, those share a factor of 4. And the lowest power of x common to both would just be x to the first. We are factoring out a 4x. Think distributive property. 4x times what is 12x squared? Positive 4 times positive 3x. 4x times 3x is 12x squared. 4x times what is negative 8x? 4x times negative 2. Here, there's nothing in common to the positive 3x and the minus 2. But since we at the very least need to factor out our sign, it's not just a plus, it is a plus 1. Anything times 1 is itself. And that's how we're going to get the 3x minus 2 here. And at any step, we can go up, make sure we get the previous step when we simplify. If we distribute this 4x through, we do get these two terms. If we distribute this positive 1, 2 through, we do get these. And if we combine these like terms, we do get what we started with. Every step can be checked by going backwards. Okay, so just like we did last time, we have a common factor of 3x minus 2. We're going to go ahead and factor that out. And what are we left with? 4x plus 1. Hopefully using these colors helps you see where these things are coming from. We can check if we FOIL. 3x times 4x is 12x squared. 3x minus 8x gives us our minus 5x. Negative 2 times positive 1 is negative 2. So this is the AC method. Now you can also write this, remember, as 4x plus 1 times 3x minus 2. The final two factors, they can be written in either order. You want to see something cool? What? Wow. Ooh. I'm in front of a green screen. Okay, not the first time I've pulled that in the video today. I don't know why I'm so amused by that. Another problem. Let's say we have 10x squared plus x minus 3. Well, Let's go ahead and do the AC method. For AC, we would have positive 10 times negative 3. So our multiplication goal, positive 10 times negative 3. We want the numbers that multiply to negative 30. And as always, since we can't see a number in front of the x, we know that's a 1x. And this positive 1 that's our addition goal. So we want to find the numbers that multiply to negative 30 and add to positive 1. Now I'm going to go ahead and list them out one more time like I've been doing, but this is something you should get used to trying to do in your head. The numbers that multiply to negative 30 and add to positive 1, it's going to be 6 and 5. We need the answer to be a positive 1, so it has to be a plus 6 and a minus 5. That's all you need to do. You just need to think it through and find those numbers. You don't have to list it out like I've been doing. But if I were listing them out, we'd need a positive times a negative, 30 and 1, 15 and 2, 10 and 3, 6 and 5. There's a set this way, but also it would be negative 30 and positive 1, negative 15 and positive 2, negative 10 and positive 3, negative 6 and positive 5. And which group adds to positive 1? The positive 6 and the negative 5. What do? Well, we use it to split the middle. So 10x squared and minus 3, that's not going to change. But we're going to split up plus 1x and rewrite it as plus 6x minus 5x. Positive 6, negative 5. Those are the numbers we found. Factor by grouping. Group the first two. And see what we can factor out. The 10 and the 6 have a common factor of 2. The x squared and the x, we can take out an x. Distributive property. 2x times what is 10x squared? 2x times 5x. 2x times what is positive 6x? 2x times positive 3. Here, nothing in common between the 5x and the 3, but we still have to factor out our sign. And when it's just the sign, it's the same as imagining a negative 1. Negative 1 times what is negative 5x? Negative 1 times positive 5x. -1 times positive 5x. -1 times what is -3? -1 times +3 is -3. 5x plus 3, 5x plus 3, that matches up. That means we can factor out this common 5x plus 3. And what are we left with? 2x minus 1. 2x minus 1. That's our answer. 5x plus 3 times the quantity 2x minus 1. And how can we check? We can FOIL. 5x plus 3 times 2x minus 1. If we multiply, FOIL first, 5x times 2x is 10x squared. Outer, 5x times -1, -5x. Inner, 3 times 2x plus 6x. Last, 3 times -1, that's -3. Combine our like terms. 10x squared, -5 plus 6, that's positive 1x, or just x, minus 3. That's what we started with. It checks. We know we're right. And that was our answer. So this is the AC method. The AC method strictly refers to finding AC as the multiplication goal, getting our two numbers, splitting up the middle term, using those two numbers so that we have a 4-term thing. And then once we have a 4-term thing, it's just more factoring by grouping. I want to show you another method. I've seen this called the airplane method. So I call it the airplane method. Don't ask me why it's called the airplane method. I'm sure there's a great reason for that. We start it the same way as the AC method. So if we were doing the same problem, 10x squared plus x minus 3, the first step would be finding AC. AC is what we get when we multiply A, positive 10, times C, negative 3. That means AC, our multiplication goal, is negative 30. B, our addition goal, still positive 1. We find the two numbers. The two numbers we found, positive 6 and negative 5. So that part doesn't change. What does change is what we do with the numbers. Remember that first way that we learned how to factor today with just setting up the two things right away and putting X and X and then just taking these numbers, putting it in and circling it. Oh, those were great times, yeah? Well, when it was an X squared, we put X and X. For the airplane method, when we have 10x squared, we're going to write 10x and 10x. Now you might be thinking, wait a minute, you're trying to trick me. 10x times 10x is 100x. We need it to be 10x, so it has to be stuff like 5x and 2x or 10x and 1x, but it can't be 10x and 10x. And that's absolutely right, it can't be. And there's going to be a step in the airplane method later on that's going to take care of that. But for now, just trust me, we're going to write 10x, 10x. And now these two numbers we found, plus 6 and minus 5, we're just going to put them in there. Now, we are not done at this step. The key to the airplane method is within each set of parentheses, if we can divide, we do divide. Don't factor out. This is just straight division, not factoring. What can we divide both 10 and 6 by? 2. So let's do it. What can we divide both 10 and 5 by? 5. So let's do it. When we do that, (10x) divided by 2 is 5x. 6 divided by 2 is 3. 10x divided by 5 is 2x. 5 divided by 5 is 1. There's our answer. And because we divided by what we could, now everything works out. 5x times 2x is 10x squared. And when we FOIL this, we do get what we started with. And that's the airplane method. And that is pretty darn easy compared to the other methods. You won't find it in the textbook. You won't find it in the homework. This is me telling you that this is how you should learn to do it. It is fast. Now, just like always, the first step in a factoring problem is factoring out the common factor. If there is a common factor to all three terms, you have to factor it out first. Do the airplane method on what's left over. Let's do the airplane method for the one we just did. Before this, what did we have? We had (12x squared minus 5x minus 2. The airplane method says since we have a 12x squared, put a 12x, put a 12x. Now let's find AC. A times C, 12 times negative 2. That means AC, our multiplication goal is negative 24. B, our addition goal is negative 5. The numbers, they haven't changed. We need it to be a negative 5, so negative 8 and positive 3. Let me put those in. Minus 8 plus 3. We're not done until we divide by what we can. Within each parenthesis set, 12 and 8 can be divided by 4. 12 and 3 can be divided by 3. This gives us 3x minus 2 times 4x plus 1. Done. And you know what? If we didn't have a number in front of the x squared, if it was, say, x squared plus 5x plus 6, the airplane method says, since we have an x squared, we put x and x. Since a is 1, AC is just 6. Our multiplication goal is 6. Our addition goal is 5. The numbers that multiply to 6 and add to 5 are plus 3 and plus 2. So we put them in. If we can divide, we do divide, and we can't divide. So we're done. I talked through the airplane method, but look what I have written down. It's our original rule. Multiply to get C, add to B. Why does it only work when x squared is x squared and not 2x squared, 3x squared? Because A is 1 and 1 times C is just going to be C. So the AC method with the factoring by grouping, that works if it's just an x squared. So all you really need to know how to do to factor trinomials is the AC method. And the airplane method makes things so much quicker. The third objective in this topic is factor by substitution. Our last examples for the day will have to do with factoring by substitution. Now, substitution means taking something and replacing it with something else. So factoring by substitution is going to be a method of factoring whereby we take something and replace it with something else. In this case, we're going to replace it with something that's going to make the problem easier. Let's say we had 2x minus 7 squared minus 3 times 2x minus 7 minus 40. And we were told factor. Well, the long way to do this problem would be to first simplify this all the way down and then factor what's left. So this would be 2x minus 7 times itself. This would be distributed, so minus 6x plus 21 minus 40. When we do FOIL, this would be 4x squared minus 28x plus 49 minus 6x plus 21 minus 40. Oh boy, 4x squared negative 28 minus 6 would be negative 34x plus 49 plus 21, that's plus 60 plus 70. 70 minus 40 would be plus 30. So then we would have this 4x squared minus 34x plus 30, and we would go on to factor from there. me write this with some room to work. Factoring a trinomial. See what we can factor out. First, we can take out a 2. We're left with 2x squared minus 17x plus 15. To factor this piece, two x squared minus 17x plus 15. AC, we would need numbers that multiply to positive 30, add to negative 17. These will be negative 15 and negative 2. Airplane method says a 2x squared gets us a 2x and a 2x. Plug in our minus 15, plug in our minus 2. Can't divide by anything here. Can divide by 2 here. We're left with 2x minus 15 times x minus 1. We're going to go ahead and this gets replaced with the 2x minus 15 and the x minus 1. This is the long way. This was not factoring by substitution. This is how we would have to do it using only the methods that we know right now. Next time we're together, I'm going to start by doing this same problem, except I'm going to show you how we can do it with substitution. We'll do more examples there, and then we'll move on into factoring binomials. Well, I said that we could do it with factoring by substitution, but I did it the long way. And that problem I did was 2x minus 7 squared minus 3 times 2x minus 7 minus 40. And the long way was expanding it all and getting a trinomial that I then went on and factored further. We got a final answer of 2 times 2x minus 15 times x minus 1, assuming this was the problem I did. If I did the one with 3x plus 1, we're going to see that. I can't remember. It's been a few days. We're going to do 2 of these anyway. If you do this the long way, you're going to get this as an answer. Here's what the short way is. We've got this thing squared minus 3 times this thing minus 40. And you can see this 2x minus 7 in both of these places. So factoring by substitution implies substitution, and that's exactly what we're going to have here. We're going to have some substitution. This, the 2x minus 7, is what we're going to substitute. We're going to make this substitution by saying, let u equal 2x minus 7. And why? Why do we do this? Well, u is the variable that we use for substitution. We could say any other letter. We just don't want it to be x, but u is the standard here. And why the 2x minus 7? Well, because think about what we would have if instead of 2x minus 7, we had u. It would be u squared minus 3 times u minus 40. And we know what to do here. We factor this, since it's a u squared, as u times u. The numbers that multiply to give us negative 40 and add to give us negative 3. Those are going to be negative 8 and positive 5. Negative 8 times positive 5 is negative 40. Negative 8 plus 5 is negative 3. So negative 8 plus 5. Now you might be saying, ha, that's not the same answer. That's not even close to the same answer. Well, that's because we're not done yet. We just factored this thing with u. The problem has x's. Chill, hang on. So what am I going to do with this u minus 8 and u plus 5? Well, first of all, I'm going to give myself more room. And I'm going to write it up top. U is 2x minus 7. So now we're going to substitute back, bring it back to the x's. This would be 2x minus 7 minus 8 times 2x minus 7 plus 5 This simplifies to 2x minus 15. This simplifies to 2x minus 2. There isn't anything we can factor out here, but this one isn't completely factored. This can factor to bring out a 2 times x minus 1. And look, that means the whole answer is 2 times x minus 1 times that 2x minus 15. There's our answer. Same three factors. And we never had to multiply it out, distribute, combine like terms. We just did a substitution to get the answer. Let me do another with substitution. And like I said, maybe this is the one I did the long way. I can't remember. Let's take a look at 3x plus 1 squared plus 2 times 3x plus 1 minus 15. Well, here, our candidate for substitution, let u equal 3x plus 1. Because then we have u squared plus 2u minus 15. U and u to give us u squared. And the numbers that multiply to give us negative 15, add to give us positive 2. These would be plus 5 and minus 3. Multiply to give negative 15, add to give positive 2, plus 5, minus 3. But u is 3x plus 1. So this is 3x plus 1 plus 5. 3x plus 1 minus 3. Three x plus 6. 3x plus 1 minus 3. That's 3x minus 2. This is not completely factored, so we have to factor 3 out. 3 times x plus 2 times 3x minus 2. And that is our final answer. And if this is the one I did the long way, hey, look, it's the same answer. One of the things I want to point out here, I didn't just divide both sides by 3 like I did with the airplane method. This wasn't the airplane method of factoring. This is just factoring completely. Once here, this is a factored form. It's just not completely factored. We're done with the process of factoring right here. This is just bringing substitution back and factoring the rest of the way. In the airplane method, if we had this and then we would divide both by 3 because we can, that's a part of getting the factored form when we use that method. The reason that we're in a situation where this can happen, where we still have to factor a 3 out at the end, is because if we were to do this the long way, once we got the thing to factor, the first step would be factor out a GCF. And that 3 would get factored out then. Since we didn't have a GCF in our U forms, we end up having to take care of the GCF getting factored out all the way at the end. We wouldn't just divide it. That 3 has to stick around. It can't just go away. Make sense? Another thing I want to say is, when I filmed the last lecture, I did not know why it was called the airplane method. And thanks to a student who went above and beyond and looked it up and let me know, I now do know why it's called the airplane method. And I will share that with all of you at a future time, because we're not going to have time to go into it today. After all, it's not the name and why it is the name that's important. The importantness is the method. I want to look at one more substitution problem, and then we'll continue on with factoring binomials. Six y to the 6th minus 5y cubed minus 4. And now you might be looking at that and going, now wait a minute. I understood where we were getting that u equals whatever in the last one. It was obvious. Here, I don't see the same thing. I don't see, this doesn't look like the last substitution problem. Now, it may not look like it, but the end goal of all substitution problems are the same. The end goal is that it's just written with u squared in u instead of whatever's there. So you don't have to necessarily see what u is right away. You can go backwards. That's how I do it. I replace what's there with the form I want, with the u squared u. So instead of 6y to the 6th, I have 6u squared. Instead of minus 5y to the 3rd, I have minus 5u squared. And why? Well, because I know how to factor this, and I'm going to use the airplane method. But before we go ahead and continue, we do need to know what u is so we can make the substitution back at the end. And once it's in the form, you should be able to line it right up. This clearly means that u and y cubed are the same. Let u equal y cubed. Since we didn't set out to make that substitution to begin with, since we kind of discovered it, we want to check and make sure that u squared is actually u squared. So u squared should be y cubed squared. Y cubed squared, multiply the exponents, would be y to the 6th. U squared would be y to the 6th, and sure enough, u squared matches up with y to the 6th. That checks, so that's true. U is y cubed, and when we're done, we'll make that substitution back. But first, airplane method. This is a 6u squared, so we're going to write 6u and 6u. The numbers that multiply to AC, that multiply to 6 times -4, -24, and add to -5. That's going to be -8 and +3. Those multiply to -24. -8 plus 3 is -5. I'm going to put that in. -8 plus 3. We're in the airplane method. That's the only place where it's okay to just divide because we can. It's the only place where we're told, hey, divide if you can. Not factor out, divide. 6 and 3 both divide by 3. 6 and 8 both divide by 2. So this is 3u minus 4 times 2u plus 1. We're not done. These are u's. Our answer needs to be y cubed. So guess what? 3y cubed minus 4 times 2y cubed plus 1. Just substitute back. Instead of u's, now we're back to y cubes. And that's our answer. There's nothing more we can do to combine. There's nothing that can be factored out of either of the two factors. Now, when we were multiplying, let's say we had 4r plus 1, the quantity squared, plus 8 times 4r plus 1, plus 16. Well, we could square the 4r plus 1, distribute the 8, combine like terms, get a completely new polynomial, and then factor that. Or we can replace 4r plus 1 with the variable x. That would make this x squared plus 8 plus 16. And that we know how to factor. We need numbers that multiply to 16 and add to 8. That's 4 and 4. So x plus 4 times x plus 4, or x plus 4 squared. Then we make the replacement back. Instead of x plus 4, it's actually 4r plus 1 plus 4, or 4r plus 5 squared. That's factoring by substitution, and that's it for this topic. The topic is factoring by special products. The first objective in this topic is factor a perfect square trinomial. So a trinomial that is the square of a binomial is called a perfect square trinomial. This may look familiar. When we were covering multiplication back in the day, we came across this special formula for squaring a binomial. Square the first plus or minus 2 times the first times the second plus the second squared. Since factoring is just multiplication in reverse, it stands to reason that this special formula factors into a squared binomial. So when we see something like x squared plus 12x plus 36, the first thing that we should notice, the first thing that we should focus in on is that the first term is something squared, namely x, and the last term is something squared, namely 6. All we have to do is check, is the middle term 2 times the first times the last? 2 times x times 6 is 12x. Since the middle term does check out, this is a perfect square trinomial. It does factor to a binomial squared. And that binomial squared is x plus 6 squared. The plus, because the first sign is a plus. That's the sign that makes the distinction between adding and subtracting. Okay, again, we notice that the first term, 16x squared, is something squared, namely 4x. I see a mistake. I fix the mistake. We notice that the last term now is something squared, namely y squared. Is the middle term 2 times the first times the second? 2 times 4x times y is 8xy. That's what we have in the middle. This is a perfect square trinomial. Since we've determined that this trinomial is a perfect square, we can factor it using the special product formula. So our A, our first thing, is 4x. We are subtracting. And our B, our second thing, is y. So 4x minus y squared.